want to discuss a new topic, stepwise and overall formation constants. Dear children, myself Dr. Digna Varghese. Stability constant. The thermodynamic stability of complexes is represented by the formation constant. A stability constant, that is also known as formation constant, binding constant, is an equilibrium constant for the formation of a complex in solution. It is actually a measure of the strength of the interaction between the reagents, metal, ion, and ligand, that come together to form the complex. The stability constant provides the information required to calculate the concentration of the complex in solution.
Stability constant. Most of the complexes are stable but may dissociate into a small extent in an aqueous solution. In each case, the equilibrium is established between an undissociated complex, that is MLN, and the fragments of dissociation, metal, iron, and the ligand. There is an equilibrium. Okay, so most of the complexes are stable but may dissociate to a small extent in aqueous solution. The dissociation to metal and ligand fragments. But there exists some equilibrium between the undissociated complex and dissociated fragments. Here you can see K is equal to, that is the equilibrium constant, is equal to M, concentration of M into concentration of L raised to N, where K dash is equal to concentration of M into concentration of L raised to N divided by the complex, concentration of complex. The smaller the value of K dash, if the smaller the value of K dash, that means the dissociation is smaller, or the extent of dissociation is smaller, and therefore the greater the stability of the complex. So the reciprocal of the dissociation constant is called stability constant. What is stability constant? The reciprocal of dissociation constant is called stability constant. Most of the complexes are stable, but they undergo some dissociation and form an equilibrium between the dissociated fragments and the undissociated fragment. Therefore, K is equal to M, concentration of M into concentration of ligand. K dash is actually the concentration of M into concentration of L divided by concentration of MLN, where K is 1 by K dash. If the value of K dash is smaller, means the complex is highly stable. If the value of K dash is high, means the complex is unstable. So actually the reciprocal of the dissociation constant is called the stability constant. Stepwise formation constants. The formation of constant describes the formation of a complex from metal cation and the ligands. That is actually the stepwise formation of a complex. Stepwise formation of a complex means a complex derived from the metal cation and ligands. The formation of a complex between metal and a bunch of ligands is usually in a substitution reaction. Based on this fact, Jerome in 1941 defined that the formation of a metal complex in aqueous solution takes place by replacing the water molecule by another ligand L. If a metal complex of in aqueous solution formed by the metal reacts with water molecules to form a meta-aqua complex, it is further reacts with another ligand. The ligand L replaces water molecules and forming a new complex of ligand L and metal. Okay, so this is a substitution reaction. Thus, the formation of the complex MLN may be supposed to take place by the n steps and equilibrium constants. So MLN, the formation of the complex MLN means there is a stepwise reaction. Okay, metal reacts with first ligand to form metal ligand, ML1 combination. Second step, M plus 2 ligands to give ML2. So for the formation of MLN complex, there may be n steps, okay, and their corresponding equilibrium constants. Here you can see metal reacts with a ligand to form a complex Ml. Its equilibrium constant is that is represented by K1, that is Ml, concentration of Ml reacts divided by concentration of M into concentration of L. This is actually the formation constant. Ml plus L in equilibrium with Ml2. Okay, here the equilibrium constant is K2. K2 is concentration of complex Ml2 divided by concentration of complex Ml into concentration of ligand. Here the first step Ml is found. Second step the Ml reacts with another ligand to form Ml2. Okay. And the third complex when this Ml2 reacts with another ligand and forming Ml3, that is K3. K3 is concentration of Ml3 divided by Ml2 into L. Therefore, for the formation of the desired MLN complex, that is from the complex MLN minus 1 reacts with a ligand L forming MLN complex and its equilibrium constant Kn is equal to concentration of MLN divided by MLN minus 1 and concentration of ligand. The equilibrium constants K1, K2, K3, etc. up to Kn are called the stepwise formation constants or stepwise stability constants. Stepwise formation of a complex, that is first formed a complex, that complex reacts with another ligand to form the next complex, that complex reacts with another ligand to form the higher complex. So if the formation of n MLN complex, there may be n steps of reaction. So this is actually the formation of stepwise formation of a complex and the constants, the equilibrium constants corresponding to the formation of complexes, that is known as stepwise formation constants. Overall formation constants or overall stability constants. The formation of a complex MLN may also be expressed by the following steps. Here you can see a metal reacts with a ligand to form a complex Ml. Its equilibrium constant here expressed in terms of beta value. So beta 1, that is the formation of complex Ml, concentration of complex Ml divided by concentration of metal into concentration of ligand. Here you can see another formation of complex Ml2. Here metal reacts with 2 moles of ligand to form Ml2. In the case of stepwise formation constant, if Ml2 is formed by the complex Ml reacts with ligand. Okay, here the reaction, the formation of complex is formed by the combination of metal and ligand, not with complex and ligand. Okay, so here the metal reacts with ligand to form Ml2 complex. Its equilibrium constant or a formation constant is beta 2, that is concentration of Ml2 by concentration of M into concentration of L square. Another reaction, metal reacts with 3 moles of ligand to form Ml3 complex. its equilibrium constant or formation constant is beta 3 is equal to concentration of Ml3 divided by concentration of M into concentration of L raised to 3. So there is formation of MLN complex, that is from the metal reacts with n number of ligands to form MLN. Beta n is the overall stability constant here, and MLN divided by M divided by concentration of M into concentration of L raised to n. Here you can see the equilibrium constants beta 1, beta 2, beta 3 and beta n for the corresponding formation of complex. So these are called overall or cumulative formation constants, or we can say that overall or cumulative stability constants. Of successive stability constant, with a few exceptions, the values of successive stability constant decreases regularly from K1 to Kn. That means K1 greater than K2, greater than K3, greater than K4, which is greater than Kn also. This is illustrated by the data for a cadmium ammonia complexes. You can see cadmium reacts with ammonia to form cadmium NH3 2 plus complex. Its value K1 value is 10 raised to 2.65. Next step, this is a stepwise formation constants. Here the complex reacts with another ammonia ligand to form CdNH3 twice 2 plus. Its K2 value is found to be 10 raised to 2.10. Next step, the complex CdNH3 twice 2 plus reacts ammonia ligand to form CdNH3 twice 2 plus. Its K3 value is 10 raised to 1.44. And the last step here, the CdNH3 thrice 2 plus reacts with ammonia ligand to form CdNH3 4 2 plus. Its K4 value is 10 raised to 0.92. Here you can see the stability constant data for the cadmium 2 NH3 system is found to be K1 greater than K2 greater than K3 greater than K4. For K4 its value is 10.92 and K1 10 raised to 2.65. So always the value, there is a successive stability constant decrease regularly from K1 to Kn. Okay. Now we are going to discuss the relationship between the stepwise and overall formation constants. You please take a piece of paper and write the derivation with me. We know that for the stepwise stability constants are for a complex formation M plus ligand to form metal ligand complex, its equilibrium constant, that is actually the stability constant, K1 is equal to concentration of complex into divided by concentration of metal into concentration of ligand. So this is the equation number 1. Second reaction is in stepwise formation of a complex. The complex formed from the first step reacts with another ligand to form Ml2. Its equilibrium constant, that is actually the stability constant for the second step, that is the K2 is equal to concentration of Ml2 divided by concentration of Ml into concentration of L. That is equation 2. Okay. And the third step, that is the complex Ml2 reacts with ligand to form Ml3 complex. Its stability constant K3 is equal to concentration of Ml3 divided by concentration of Ml2 into concentration of ligand. That is equation 3. The product of K1 into K2 into K3 may be equation 1 into 2 into 3. That is, you can write as concentration of ml into divided by concentration of m into concentration of L for K1. For K2, concentration of ml2 divided by concentration of ml into concentration of L. For K3, concentration of ml3 divided by concentration of ml2 into concentration of L. If we are going to cancel the common term here, that is, this is a common term and here also, so they're cancelling, and ml2 is also cancelling. Therefore, the product of K1 into K2 into K3 may be equal to concentration of ml3 divided by concentration of m into concentration of L. Okay, raised to 3. This is equation number 4. Now we are going to calculate beta 3, that is the overall formation constant in third step. Okay, that is we can directly written as m plus 3l in equilibrium with ml3, that is beta 3 is equal to concentration of ml3 divided by concentration of m into concentration of L raised to 3. This is the same as this product is the value of beta 3 is the same as that of the product of K1 into K2 into K3 in equation 4. So these are equal. Therefore, we can say that beta 3 is equal to product of K1 into K2 into K3. Okay. In general, the product of successive stability constant is equal to the overall formation constant. If it is a beta 5, to calculate beta 5, then beta 5 is equal to K1 into K2 into K3 into K4 into K5 and so on. Okay. So we can say that beta n is equal to sigma n into K raised to n n. Okay. N, if it is beta 1, if n value is 1. If it is 2, n value is 2. Or log beta n, we can write in this way, log k1 plus log k2 plus log k3. So in general, we can say that product of successive stability constant is equal to the overall stability constant. If for beta 2 calculation, k1 into k2. Beta 2 is equal to k1 into k2. If beta n is equal to k1 into k2 into k3 into k4 into etc. up to kn. Okay. Thank you so much for your attention.